Hello, this is Mr. Chan here to do a Topic 3 review for Algebra 1. Please grab your packets, turn to page 135, and let's get started. This particular review is only going to cover 3 sections. They are 3.1, 3.2, and 3.5. The other sections have been glossed over. So starting on page 135, we have some vocabulary here. And we're actually going to answer 2 of the questions. They are number 2 and number 5. The other ones are not related to those 3 sections. So here we go. When y tends to increase as x increases, the 2 data sets have a blank. And the answer is positive association. Great. Number 5, a trend line that most closely models the relationship between 2 variables displayed in a scatter plot is the line of best fit. Okay, that was pretty easy. Let's go ahead and get started on the first section now, 3-1, called Relations and Functions. Some vocabulary here, of course. A function is a relation in which every input or element of the domain is associated with exactly one output or element of the range. Function, every x value, basically, that's the domain that we refer to usually, is associated with exactly one output or element of the range. Those are the y values, usually. And sometimes you might see me write this. Every x value has a unique y value. Okay. Example, identify the domain and range of the ordered pairs in the table. Do the ordered pairs represent a function? Justify your response. So if you look at the domain, which they've listed just below that table, and then you can see each of the elements in the domain has exactly one y value. Okay, there's not more than one x value. So in this case, the answer is yes. This particular relation is a function. Every x value has a unique y value. Number 7. Not a lot of room here. You might need to get some scratch paper. I kind of zoomed out a little bit. I'm going to write to the right side of this review here. Identify the domain and range of each relation. Let's do number 7 first. I'm going to use the function notation. Sorry, set notation, I meant to say, with the curly braces. The domain are the first values of each pair. For number 7, the domain is 4, 2, 0, 5. That's all. The range, of course, are the second values of each pair. In this case, they are 1, 3, 4, and 3. Question. Does every x value have a unique y value? 4 is mapped to 1, 2 goes to 3, 0 goes to 4, and 5 goes to 3. That's okay. 2 goes to 3, 5 goes to 3, that's okay. It's for every x value, it goes to every y value. That's the important part. We don't mention anything about y going to x. So number 7, the answer is yes. It's a function. How about number 8? Let's deal with that. We have 5 pairs of numbers in this case. My set notation here will include the first row with that table. Pretty easy, it's all there for me to jot down. The range will be the second row. And that's it. Take a look at your x values there, -1, -5, 4, 0, 2. Nothing is repeated there. So yes, every x value does connect to every one single y value. So this is also a function as well. All right. Number 9 and number 10 are kind of interesting. It's a very subtle question. Would a reasonable domain include all real numbers? Now, real numbers are like all the whole numbers and their opposites, the decimals and fractions. And look at number 9 and number 10. These are real world problems. Real world numbers include negative numbers, so both of them cannot be negative. I mean, a sports drink, there's no such thing as a negative ounce of liquid. For a printer, there's no such thing as a negative number of pages. So for both of those, I would say no. Cannot be negative. All right. Any questions about the first section? Let's go ahead and move on to the second section, 3-2. We're going to skip 11 and 12 there. All right. Here we go. Next page. Okay. Linear functions are next, 3-2. Linear function is a function whose graph is a straight line, hence the name linear. It represents a linear relationship between two variables. A linear function written in function notation is f of x equals mx plus b. Now, we've done linear equations before. A function is using this new type of notation. F of x is how you say that, f of x. I mean, it's not like we're multiplying the letter f with the letter x. F of x literally replaces the letter y. It gives you more information, okay? X is the independent variable. Y is the dependent variable. The function depends on the x value. Often the example we have a taxi company charging $3.50 plus 85 cents per mile. So the 350 is fixed value. It doesn't go anywhere. Okay, it's a constant. But every mile that the cab travels or the taxi, it costs 85 cents. Hence we have 85 per distance in miles. And that's where we get that formula, 0.85d plus 3.5. Question, how much would a 3.5 mile taxi ride cost? 3.5 is referring to the actual distance. And that goes in right there. Do a little calculation. Looks like it's going to be $6.48 rounded to the nearest penny. All right, that's pretty easy. Let's take a look at number 13 here, off to the right. Evaluate each function for the elements in the domain -4, -2, 0, 2, and 4. Basically, number 13 is 5 little problems thrown together. I'm going to use function notation to kind of get you guys used to that. F of x equals 2x minus 1 is the formula. And remember, f of x means the letter y now, okay? What we're doing is I'm going to represent plugging in -4, -2, 0, 2, and 4 using function notation. F of x equals to 2x minus 1. And I'm going to do this 5 times. Holy cow. Each time will be a different element from the domain. I am plugging in -4, -2, 0, 2, and 4. Okay. Now remember, this means y. I'm actually going to put in literally in that spot where x used to exist. Now I'm replacing it with the actual number. Let's clean it up. 2 times -4 is -8. -8 minus 1 is -9, and so on and so forth. You've actually done this before in a previous chapter involving mx plus b. And there we are. Evaluate each function. There are your answers. -4, 9, -5, 2, -5, 0, -1, 2, 3, and 4, 7. Those are actual coordinate points. Hey, we'll do the same thing for number 14. Different, same process, different numbers. Oh, they don't use x's, they're going to use t's, kind of interesting. Again, we're going to put in 5 domain values. And they are, of course, -4 through +4. And be careful here, order of operations. You must do the parentheses first. Before multiplying. Whoops, caught myself. Negative times a negative is a positive. Dun, 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 dun. And there they are, my y values. Yay. Any questions? Well, let's do one more in this section. Let's skip 16, but do 15. Make sense and persevere. Melissa runs a graphic design business. She charges by the page and has a setup fee. Okay. So a setup fee means no matter how many pages she makes, there is an initial amount. The table shows her earnings for the last few projects. What is her per page rate? And what is her setup fee? Okay. So when it comes to these types of tables, you want to look for where you have 0 pages. And I'm looking at this right now, and it only shows 2, 4, 6, and 8. If I were to go backwards of adding, instead of adding 2, I'm going to go ahead and subtract 2 to go backwards in the table. That will give me what the setup fee will be. So if I subtract 2, I'll get 0. And let's look for the pattern for the cost. The cost looks like to me, if I take $335 minus 185, looks like it's going to be $150 for every 2 pages. But if I go backwards from 185 and subtract the 150, I'll get $35. Interesting. Boom. Minus 150, I'll get $35. And there it is. $35 is the setup fee. Very good. And the per page rate looks like half of 150, and that's $75 per page. Let's see, do they ask for the actual equation? We can actually come up with an equation right now. But let's do that, even though they don't ask. We'll use, I don't know, cost is in dollars per page. So we'll do CP, I guess, cost per page. And that equals to $75 per page plus $35 setup fee. And there's your function. Okay, you can use f of x, whatever. All right. That takes care of the second section. Let's move on to the next section, 3-5. We're going to skip 3.3 for this year. We're actually skip that one. And we're asked to skip 3.4 as well this year. So you don't have to worry about 3.3 or 3.4 on the final or on your test. But let's jump to section 3.5 on page 138. Here we go. Scatter plots. All right. Scatter plots are basically taking real world data and plotting them on a coordinate plane. And we have some relationships when we see trends or things called line of best fit. A positive association is when the y values tend to increase as x values increase, and a negative association is where they go in opposite directions, okay? Positive association, et cetera, okay? Okay, so line of best fit, we'll talk about that also. That's basically mx plus b. It's a line. The opener example is Yama takes a course to improve his typing speed. A scatter plot shows his progress over 6 weeks. Great. What is the relationship between the number of weeks and Yama's typing speed? As you can see, this is called a scatter plot. And if we kind of eyeball a line that will fit through those points, it's actually going uphill from left to right. This is considered to be a positive association. Because my slope is positive. And that's how they're related. Let's take a look at the first example in this section. Describe the association. Now, number 29, it's like there's really no trend here. It's like all over the place. This particular situation is there is no association. Whereas number 30, if we would have put a line of best fit through those 8 points, not the best, but close enough, this is considered to have a negative association for number 30. Yay. And I think that is all we have to do today. Thank you very much. If you have any questions, please let me know.
Shower.
I'll talk to you later. Thank you. Have a good, nice day.